Okay, I'm going to make a start. So welcome, my name's Ulrich Roxburgh. I work for I run a small architectural consultancy firm based here in Auckland, but I work typically throughout Australasia, in Sydney and Melbourne, Wellington, Christchurch. I've done work in all of those places. Today's talk, Get Out and Take Your Data With You, is a talk that originally I had planned to put into the development track. This was actually a talk I proposed and put into the development track and or the cloud track, because cloud of course is catchy and you've got to have that in your presentation somewhere. And then I was requested, could you put it into the architecture track? So I thought, okay, so I refactored the talk and we now have an architecture talk. Just after I'd refactored it the first time, they said to me, oh, by the way, architects don't like to see code, so take the code out. Oh, bugger, I said. That's the best bit. So the code's in there, but it's not inside Visual Studio. That's my kind of justification. I can say quite clearly, no, not going anywhere near Visual Studio. We're safe. So this talk is about the Microsoft Sync Framework version 2, or now 2.1, since they just released a small upgrade. And it's about the kinds of applications that this toolkit enables. So we're going to talk firstly about different kinds of applications that you're likely to build and some of the challenges that you'll experience. And we're going to look at a particular kind of application called an occasionally connected application. Then we'll introduce the Sync Framework and explain the features and benefits of it. Take a look at some data synchronization basics, and then look at how easy it is to add data synchronization to your application. And we will talk about the cloud, because it's actually relevant. So, looking at our enterprise application model, we have inside the big green box a big corporate network environment, and to date, or initially, we started by building client-server apps or end-tier applications that ran inside the network. The number of hops to the database or whatever system you were connecting to were comparatively small. The latency to get there was comparatively small. If you wrote poor stored procedures or had the wrong granularity in your method calls, you probably didn't notice. Things worked reasonably well. And because the number of people that were using your application essentially all had to exist inside your enterprise, scalability typically wasn't a problem either. I'm not saying always, but obviously you didn't have to think about it quite so hard. Of course, a few years after that, we started building the old web apps, and suddenly scalability was more of a problem because a lot more people were hitting the data. So the web apps accessed your data from outside the network, but that's actually slightly untrue. The data or the web application code still resided inside the network and, of course, accessed the data locally, so data access was still quick. And what gets sent down to the browser isn't the data at all, it's a picture of the data. So a few years later, of course, we came up with web services. Now we really were pushing data down, and we were on our desktops or on our Windows phone or some external device, we were writing applications that were talking through web services to our data store. Of course, scalability now becomes more of an issue, and the network latency becomes an issue. In my previous talk, I gave the example of when we were writing a client application for Commonwealth Bank. When they first started developing it, it all seemed all okay until they took the application over to Perth, which is 3 time zones away, and suddenly latency just killed the initial version of that application. So there are some issues with that. And of course, the other aspect that was happening around about that time was a bit of tension between 2 types of apps. What we used to call thick client and thin client. So web applications and other applications. And some of the trade-offs were things like how easy it was to upgrade and things like that. A lot of those things got solved, and Microsoft's term for the new application space, if you like, was smart client applications. So these were applications that could use click once for easy deployment of new versions. They used web services so that you could build a thin client and a smart client application that used the same services at the server, so it was only the client code itself that changed. Lots of pretty cool features. There were still issues, though, with a smart client application in that if you had intermittent database connectivity, of course, your smart client application just didn't work. And, I mean, New Zealand's famous for having relatively unsophisticated internet access, especially out, in the provinces. So if you're working for someone like Fonterra and you're trying to build an application, like they have quite a big set of applications for, for the farmers and that. Obviously, they have to be connected for those applications to work, whether it be a smart client or a web app. The other issue is scalability. Now, a lot more people are hitting your server, and the traffic is small amounts of data at one time, but lots and lots of hits. And data access speeds. Typically not the actual speed of the data over the wire, but the latency of connecting to the server that you need, causing issues with just how responsive and how useful this application is. So we have a bunch of potential disadvantages that mean that our smart client just doesn't perform as responsively and isn't as elegant as a client that's sitting on the network. But we still want to get our smart clients out there. We want people to use them. So scenarios like branch offices, scenarios like people going around and collecting information at farms, scenarios like a district health board that receives input from all the dental nurses and has that information come back to the central DHB, those kinds of applications. And we want an efficient means to enter that information, and we want to avoid some of the requirements of being permanently connected. Hence the term occasionally connected applications. So to build an occasionally connected application, I need to be able to continue working at it when my network goes down or my connection goes down. Now, there are a lot of ways you can architect this and you can build this inside your application so that you do a web service call and it essentially queues up web service calls and then plays them back later on. But most of the time you find yourself jumping through hoops to make this happen. It's not a natural programming model. You're constantly having to think, what can I do if the network goes down at this point in time? And it's complex. So the other alternative is that you have a database locally and that you synchronize the changes. And that's what we're talking about today. So an occasionally connected application requires data synchronization capabilities. So we write our application pretty much exactly the same way as we would write the application if it was sitting inside the corporate. And then we rely on some other service at the moment, we'll just talk about it like that, to make sure that the appropriate data travels backwards and forwards to the host. So this takes care of most of the disadvantages. Users don't require constant network connection. They're not limited by network speed. You're on your local machine. Common application code. The code is exactly the same as the code written inside the enterprise. And we offload processing requirements because now instead of doing lots and lots of small hits, we're just going to stream a bunch of data every now and then, which will be all the changes. And if you think about your typical application, that's actually probably only 10% of the actual data that's going into and out of that application. Because if you think typically you'll, say you're doing a policy renewal for a life insurance policy or something, you'll go and get a bunch of reference data that doesn't typically change much, make some changes to the particular person's policy and then put that information back in the database. None of the reference data has changed. It's only the small amount of information that that person's typed in for the new policy. So the information flowing back to the central database is comparatively small. And of course, if the central database makes changes to the reference data, you'll get that down. But typically those changes are not wholesale changes. They're just minor changes. So the two scenarios that I'm targeting here, or that I'm looking at here, one is a corporate environment up the top with remote offices. So the remote offices have workgroup servers. So think of, I'll pick on the warehouse, for example. They have a central corporate office across the North Shore. They have, I don't know how many thousand stores around New Zealand. They can have a server sitting at each store with a database on it, and that data can automatically synchronise back with the head office. Kiosks for ASB Bank that exist in all the shopping malls. You can go up to a kiosk and look at other banking services, that kind of stuff. And then fully standalone applications. So this is your insurance broker with an application that has all the latest information about where you live and what the policy information is and all that kind of stuff on his laptop. He arrives around your house. You don't have a network connection, so therefore he doesn't have one. Oh, you could have a 3G one, admittedly, but he can run his application, and then when he goes back to his office, automatically syncs back to whichever insurance company is involved. So that's a standalone application, and of course for rural, for rural situations, that kind of thing is fantastic as well. So as an example of that application, I was working for the Department of the Environment over in Australia, in Brisbane, and they have guys go out and inspect farms over there because they have them all geographically mapped and they know exactly how much of that farm is, is in grass and how much of it's in bush. And if you surreptitiously go out with a chainsaw, they get pretty upset. You have to actually apply, and they come out and they analyse all kinds of things: salinity, water, runoff, that kind of stuff. And so those guys go right out in the bush. They have no, connectivity at all. So from their branch office, they download the information that they need prior to their trip, and that's cached locally, and then they go out and do their trip. Obviously, they add to the information. When they get back to the branch office, that information's updated. So some of the challenges associated with data synchronization. Of course, you can roll your own. But there are some big issues. Firstly, how do you track changes in the data? So if you just think about a single table inside SQL Server, how do you track inserts? How do you track updates? And how do you track deletes? And do that in a way that the application doesn't have to do extra stuff. The application should be written in terms of, I'm just making changes, exactly the way I expect to make changes. And then once you implement that, how do you maintain that change data? So if you just look at a generic database, ignore SQL for a minute, then the way you do the change tracking is you have a row version number. That takes care of the inserts and updates, because you can say, give me all the rows whose version has changed since I last synchronized with you. But you have to also insert a trigger in an extra table to basically remove the columns of data that you want to delete. Either that, or you put a soft delete flag on the end of the row. And so you have to maintain that change data. So they sometimes call it tombstones. You have to clean out the tombstones every now and then. Another issue is conflict detection and resolution. So going back to my generic database, how do you tell if user A goes in and makes a change, and then user B goes in and he makes a change, who wins? So firstly, you've got to detect the conflict, detect the fact that a conflicting change has been made. And secondly, you have to have a policy that dictates what you're going to do about it. That policy can be really simple. It can be last man wins. It can be the person with the highest priority wins. or it can be much, much more subtle and rely on business rules. You also want to, in some of the scenarios I've talked about, be able to prioritise your data exchange. For example, the loan guy might have gathered a whole lot of extra data from this person when he was processing their loan, but the first thing he wants to do is get the new loan application off. That's the priority, to get that one off. He can update the other stuff later. And if you're on a slow connection, obviously you do want to do that. You want to prioritise the synchronisation. You want to be able to synchronise in the background because nobody wants to sit there and say, sorry, application busy, you can't do anything. So it has to happen as a thread in the background. And probably the hardest one to solve if you're trying to roll this yourself is multiple synchronization topologies. By that I mean, imagine a scenario where I have a central office courier company, a central office, and I have several other pickup depots around the city, and my courier drivers go in and basically pick up a day's worth of jobs. Courier driver A finishes his day early and meets up with courier driver B. He should be able to synchronize with courier driver B, pick up some of his jobs. So this is a client-to-client synchronization. And then when each of them finishes, they don't even have to finish back at the central depot. They can finish at whichever depot is the nearest one. So now we've got a client-master replication between the courier driver and the depot. And then the depots have to synchronize with Central so that Central knows what's going on. It's a master-to-master replication. So you can see that there's quite a lot of complexity potentially in being able to do this. And last, security. How do you secure the transport of the data if it's going over the internet? Obviously, if it's on a VPN, you're probably less concerned. Oh, true, I did. Okay. So, SQL, it would be nice, well, I guess Microsoft would think it would be nice if the whole world was running on SQL. We're not all running on SQL. There's going to be not only not Microsoft databases, but not OLADB databases, not ADO accessible databases. There might be databases that are file systems, XML files in a file system or something like that. So it'd be nice if we can include that in our synchronization technology. Excuse me. Okay, so as I said, Microsoft introduced the Sync framework about 3 years ago. Version 1 provided file synchronization and general OLADB database synchronization, with the implication, especially in the database case, that you had to basically manage the detection of change. And you had to do that using a row version or something like that. In, I think it was January this year, they released version 2, which now provides some extra synchronization providers, in particular to do with SQL Server. So the Sync framework supports pretty much any Sync ecosystem because you can integrate through the providers any kind of data that you can write code against to say this data's changed. Microsoft out of the box provides a file, well, we'll be talking about them in a minute, a file system provider and a data provider, and allows you to build your own custom providers for any scenario that you haven't come across. But we'll talk about that in a second. So we can add Sync support for new and existing applications, services, and devices. Does anybody here use SyncToy? Yeah, a few of you. So for those of the rest of you, do a search on Microsoft.com, look for SyncToy. It's a file-based, basically a folder synchronizer that uses the Sync framework. It's fantastic. I mean, if you can't use folder replication for whatever reason, and you want two folders to stay in sync, or you just want to copy the changes from one folder to another folder, this tool, you just basically give it the two folders, specify the kind of synchronization, say go, and off it goes and does the job. And that uses this framework.
Just really quickly, what's the relationship between Live Mesh and the Sync framework? Are they completely separate? I
suspect that, well, the Sync framework is basically just a toolkit. I suspect that a lot of the live mesh stuff is done using the tools behind the Sync framework. Okay, so some capabilities. Well, firstly, any data store. Obviously, out of the box, you get the database style data stores, SQL plus, Oracle plus, all the ones that you can do with ADO.NET. And you get file-based data stores, but you can build your own custom ones. Any data type. So the Sync framework doesn't really care about data type. It has this concept of metadata that tells it, okay, how do I tell whether this thing's has been synchronized or not? Any protocol. So my two sync providers, my two data sources can be synchronized using whatever their native mechanism is. In the case of SQL, it's putting SQL information over port 1433 and carrying on. But you can basically synchronize across WCF, which means that you can use all of WCF's security, streaming capability, different protocols, TCP/IP, HTTP, whatever, and stream the information across. And that pretty much means any network configuration, because you can set up TCP to use whatever's, set up WCF to use whatever protocol suits your particular network conditions. The core components in the Sync framework are the database synchronization providers. We'll cover them in more detail shortly. The file sync providers. There's also a web feed synchronization component. What that is used for is automatically providing, for example, an XML feed based on the contents of a data store. So if you want to expose an RSS feed based on files in a file system, you can do that with the Sync framework. You can set up the Sync framework so that when I drop a new file into the file system, it'll automatically update the RSS feed. And you'll see lots of other potential uses for that as well. There's the metadata storage services, so that's the ability to provide some kind of data store agnostic description of the data so that the Sync framework can work with it and decide whether or not that data's changed. And then there's the runtime, the core API and runtime, which we'll see once we get to the code bit. So, developing with the Sync framework. So here's, it's got a bit blurry, sorry, but basically we have two applications, one on the left, one on the right. We have the synchronization Sync framework available in both places, and applications sitting across the two. We'll cover the different network topologies a little bit more later on, but this is a very simple example. The developer, i.e. you, has to write the application, obviously. You have to write the transport if you want to use a custom transport like WCF transport. And obviously you need to build your own data store. If it's SQL, I mean, that's a case of building the table. You've probably already got it. The Sync framework provides the synchronization session or manager and the synchronization runtime. And then optionally, depending on what exactly you're building, the Sync framework may provide the sync provider if it's SQL or a database sync provider or a file sync provider, or you will have to provide it if you want to build a custom one, obviously. And that's still relatively easy to do, though. And the metadata store. So the synchronization flow is basically that the start is initiated with the destination. The destination prepares and sends its knowledge of its data down to the source. In other words, it looks in its metadata store and it says, okay, do I have any changes to report? And sends them down to the source. Change version and knowledge and source knowledge is sent back to the destination. That tells the destination what it needs to send down, and conflicts are detected and resolved. And so then the destination sends data down to the source, and then eventually the source sends back up to the destination. That's assuming it's a two-way sync. Often they could be one-way syncs as well. So it's a relatively simple flow. You don't need to worry about that, though, because most of it's done for you. So a little bit of terminology. before we actually get into the examples. So firstly, participants. So we have three kinds of participants as far as the Sync framework is concerned. A full participant is capable of storing data and of executing code to basically tell the Sync framework what data's changed, that kind of stuff. So a database, a mobile phone with Windows CE database on it, that kind of stuff is a full participant. A partial participant can store data, but it can't run any code. So the Sync framework has to be able to get at that, to be able to interrogate it, to find out what information is changed on that device. So I talked to you just now about SyncToy. I can take a USB drive, and I do for one or two of my customers, and slap it on the side of my laptop and synchronize that customer's folder on my laptop with the USB drive, and then I can plug it into their computer and basically do another synchronization from my thumb drive, from my little thumb drive over to their machine. That's an example of using a partial participant. The thumb drive can store data, but it doesn't have any capability of processing. And then there are really simple participants, which are devices that are only capable of providing information when requested. So that's an RSS feed, a web service. They just send some information to you. Change tracking. So change tracking provides a list of changes made from one point in time to another. As I have already said, typically that's implemented using a row version for the inserts and updates, and a trigger with a deleted table or a soft delete flag. It's a huge pain if you do have to implement the change tracking like this, simply because typically you're handed a database and they don't want you going and messing around with the schema. So quite fortunately, SQL Server 2008 now has built-in change tracking. If you want to do change tracking on a table, I can't remember the exact syntax, but there's a statement that basically says alter table, set change tracking on, something that simple. And it's very, very efficient too. It's much more efficient than the other mechanism, because the other mechanism typically requires triggers and things like that. The only implication, or the only overhead, is essentially the same as adding an extra index to your table. So it's very, very efficient. And the Sync framework, Sync providers in version 2 and 2.1 take advantage of this, so that they've produced three new providers that are SQL-specific Sync providers, and they take advantage of this SQL Server change tracking, which means that you can now set them up making no changes to your schema whatsoever, which is pretty neat. So all of the change tracking information is internal to the SQL engine. Conflict resolution occurs when two databases make changes to the same data at the same time. And as I said, there's various ways to resolve it. Last change to come in wins. Highest priority user wins. You can do manual update, or you can basically pop up a dialog and say which one do you want to go ahead. That kind of thing. And I mean, if you think about, for example, Microsoft folder replication, it tells you sometimes things are in conflict because you've changed them in two places at the same time. The Sync framework provides the automatic conflict detection, and you can implement any of the automated mechanisms for resolution. Obviously, if it's manual, you've got to write some extra code. But if you want to, for example, set it up so that the last writer wins, then that's really simple to do. It does that using the metadata that's available to it. And as I said, SQL Server 2008 with the new change tracking makes it really easy to identify conflicts. So the sync providers that come out of the box, the database sync providers, so there's ADO.NET sync providers, and as I said, for those ones, you have to come up with a way of identifying the things that have changed. and the SQL Server Sync providers, which you don't. It's done for you. They can be used to synchronize databases for collaborative scenarios. That is to say, multiple people working away and making changes to a centralized database, or making changes to their database, which then get fed through to the synchronized database. So that's my, hang on one sec. It does. I'll come to that shortly. Okay, so the collaborative scenario is your branch office. There are local SQL servers, people are working away, and the information is brought back to some central place. And then there's the offline scenarios where I'm making changes to my local SQL, which is disconnected. And at some stage, either by schedule or by explicit action, I synchronize the thing. File-based synchronization provider. So this is what's used in the sync toy. So this can look at two directories on NTFS or network locations and basically synchronize it. And if you actually go into a Windows Explorer and say show all files, you'll see there's a little XML file in there. That's the metadata that it uses. So it basically puts some information in there that says I last synchronized this folder with the following other party at such and such a date, and it uses that information to then scan through and say, here's the files that have changed. There's a bit more to it than that because, of course, it's got to handle file deletes and things like that as well. But that's basically how it works. And custom providers. So you can write your own custom provider. So if you have a custom data store, whether that be an in-memory database, some kind of file in the file system, with information inside it, you can write a custom provider where you specify this is the stuff that's changed in this thing since it was last synchronized. There's plenty of examples in the SDK for that. The database sync providers, so DB sync, server sync provider and SQL CE client sync provider support the offline scenario only. So that means that I can be working away with them and then periodically I can say, okay, synchronize. So they're not as complex. They can't participate in topologies with other providers. Remember I talked before about that quite complex example of the courier driver that was synchronizing both with a peer, i.e. his buddy courier driver, a branch office, and a central location. So those are multiple different topologies. This can only, these first two providers can only support a client-server style. In other words, there's a master data source somewhere, I'm the client data source, and I'm synchronizing with that. The SQL sync provider, SQL CE sync provider, and DB sync provider support collaborative scenarios. So you can do all the different topologies I talked about. So suitable for peer-to-peer and mixed topologies. Much more flexible. So for example, just a simple example, I can synchronize a SQL database with a SQL CE database. And they use the sync framework metadata so that we can do various different sync framework topologies. Just drilling in for a second on the SQL and SQL CE providers. So these are the ones that use the SQL Server 2008 change tracking. We don't need to make schema changes. Triggers are not used, so it's much faster, and the logic is all internal to the SQL Server engine. The SQL CE sync provider is used for SQL Server compact databases. The SQL sync provider is used for everything else, including SQL Express. Which brings me to some interesting possibilities when I now want to build my applications, because as you'll be well aware, the scalability of data support, or whatever you want to call it, of basically of your data store is huge. It starts right down from SQL Compact or SQL CE on my Windows phone, on my little mobile, or I can distribute it to 1,000 customers as a single file that sits on their system, progressively up to SQL Server 2008 R2 Express, which now does 10 gigabit databases. It's a pretty competent database engine, totally free, and so I can distribute that to my clients as well, you know, if they're clients talking to maybe a central database of mine. Then we get into the paid versions, Standard, Enterprise, and two new ones, Parallel Data Warehouse and Data Center. So Parallel Data Warehouse, a massively parallel SQL implementation. I very much doubt we're going to require that in New Zealand anytime soon, or possibly there's a couple of customers that might almost use it. And then the last one is in the cloud, SQL Azure. So we have the potential to build some pretty compelling applications, and scale is not really an issue, certainly for New Zealand. We can build some pretty impressive, you know, widespread data systems. There are some other alternatives for synchronization. Remote data access, used to sync SQL Server Compact with SQL Server. Doesn't support sync using services. In other words, you've got to be pretty much on the same network segment. You can't go using WCF. Doesn't support incremental change tracking and or conflict resolution, conflict detection and resolution. So probably not as competent, for, you know, or not as useful to you as the sync framework. And merge replication, used to synchronize different editions of SQL Server, doesn't support using services or heterogeneous databases. So if the database on your client is significantly different in shape, look, to your server, then it's probably not going to work. How are we going for time? Not too bad. Two basic architectures. So this is the simple in-house, so to speak, architecture. That is to say, the network segment between your application and the external or the external data source is probably, you know, port 1433. So yes, you can run this over a VPN, and this can do your synchronization in that scenario. So we have data at one end, we have sync providers for the two data sources, and we have the sync frameworks orchestrator to manage the synchronization. So this might be a scenario where we have branch offices with local SQL servers to speed things up. They have a VPN connection back to a central office where the main data source sits, and periodically at midnight, overnight, whatever suits, synchronization happens. And the one that I personally find a lot more interesting, the idea of a completely remote, occasionally connected application sitting over that side, which, sitting over this side, which has a connection via WCF to a server application sitting in my office. The server application publishes a WCF service that does the synchronization. It's the endpoint. So, of course, I have a proxy to that WCF service in my application, and I can go ahead and build that. It's pretty simple to build. It's actually not a lot more work than the previous example that I showed you. You just need to basically define the interface in the service and select, you know, things like, okay, what port am I going to go over and what's my security and stuff like that. But the actual building of the service is relatively simple. So, how do we implement it? I promised you some code. So, sorry, but this is the best I could come up with. But it's probably easier to read like this. So, to define, there's about 3 slides of code to basically set this up. Wouldn't bother planning on, you know, copying this because it's all just easily available in the Sync Framework documentation. But just to explain how easy it is. So we start by creating a scope. You can have multiple scopes and synchronize, you know, all of them, go through them all. So depending on the characteristics of your data and the information, you can decide. So basically you create a scope and then you add one or more tables to that scope. What that does is it gets the metadata out of the table. So this is a SQL Server example, remember. This is getting the metadata out of the table, and it says what information is available in this table for synchronization. I add that description to the scope.
Can I restrict that, by the way? Can I restrict the table?
we're coming to the restriction in about 3 slides. Okay, we then provision the server. So what this does is it potentially sets up the table in the server if it isn't already set up. Now this is my master table, so it is already set up, which is why I pass it an argument. Where are we? DB sync creation option .skip. It says don't create the database table, but it still does something useful. It sets change tracking on the table because presumably it hasn't been set yet. The reason that we have that .skip is because in the case of the master, it's already created that table. In the case of the client, because presumably you've written an application at this end that's doing something interesting, and so you've already created the table and filled it. In the case of the client, that hasn't happened yet. We then server provision.apply, that actually does the job. Now we're going to provision the client. So pretty much the same thing. We create a scope description for the client, or we get the description for the product scope that we set up on the server. Then we set up the provisioning scope, and we apply the provisioning scope. This time, no flag to say don't create the table. So this is a blank SQL Express database, and it's going to create a exact copy of that table in the client database. And we're almost there. We then create our sync orchestrator. We tell the sync orchestrator, okay, local is here and remote is over there, pointing to the 2 providers. And then we say, what direction do we want to synchronize? We can synchronize going up, going down, or both, obviously. So we're doing both. And then we just say synchronize, about 10 lines of code. Some pretty complex things are catered for, though, in those 10 lines of code. So this is the example. This is the first of the graphical examples I gave. This is without the WCF bindings and that. There would have been just too much code to produce to have done that. Now, I'll very quickly gloss over this. After you've synchronized, you can get a bunch of results to tell you when sync started, when sync stopped, how many changes were uploaded, how many changes were downloaded. So that's just some useful information. And it also tells you failures. Now you want to know about filtering. I can set up a scope, pretty much the same as before, set the table default descriptions, and then say set the filter column on particular rows in the table. And this says, in this particular case, that the origin state has to equal NC. And so it will only synchronize the rows in the table that are that particular value, NC. So this example is sales reps. Okay, this sales rep only works in this particular state. We only want to give them information about this particular state. Server provision.apply. So that's row level filtering. You can also filter on columns. What filtering on columns does is it says when you synchronize, only synchronize rows where changes have occurred in these columns. So you can filter it both ways. Okay, that was a very quick how to do it with SQL Server. Now, you'll be pleased to know they have in 2.1, well, sorry, when they released Sync Framework 2.0, they almost immediately released as a separate download an adapter for SQL Azure. This is now built into 2.1, and basically you have 2 possibilities again for the way you synchronize this. You can do a 2-tier architecture, which I guess 2-tier is a bad thing to call it because it has become a bit of a bad word. You know, everybody's supposed to be doing 3-tier or more, but anyway, 2-tier architecture. It's basically for synchronizing a SQL database with a database in the cloud. So now your central office can upload some data to the cloud, and wherever you happen to be in the world, you can connect on the internet. That main office does not need to keep a public-facing web service available for you. It's all handled up. It's up in the cloud, and you can now go and synchronize with the database up in the cloud using WCF protocols. And you can also do an N-tier architecture. So this time you actually upload a Sync Framework database provider that runs inside Windows Azure as a hosted service. And it communicates with a proxy provider that works on the local computer. So now SQL Azure is going down to your machine and pulling information up and storing that on the cloud. And then, of course, presumably being picked up by some other application. And yes, we've got some code for that too. So I've done the first bit I've omitted for brevity because it's exactly the same as it is for SQL Server. So then we create a provisioning object for customers and apply it to the on-premise database. So the on-premise database, we provision the on-premise database and we apply that provisioning. And then we provision the SQL Azure database from the on-premise SQL Server database. So that will create the appropriate tables in SQL Azure, and we apply that. And at that point, I haven't put the synchronization step in, but the synchronization happens just as before. You basically set the direction, say apply, and you're basically synchronizing with the cloud. The Windows Azure hosted service, if we're doing the N-tier model, is the middle tier and communicates between a local proxy and SQL Azure. To implement that, we create a component that implements the service contract and calls the SQL Sync provider, which has been hosted up on SQL Azure. That component is deployed as a hosted service. So that's it. Thank you for listening. And do we have any questions? Okay, so to answer the first question, no, replication won't disappear because replication is about typically about a lot of data and data that's maintained in the corporate network but is replicated between two different systems. So I'm possibly doing them a disservice, but for example, ASB maintain data both in Wellington and Auckland. And so replication between the two is, you do that during using replication services because they have a high-speed, network between the two places. This is about comparatively small amounts of data changing in a lot of different places being replicated back to a central repository. And the second, how well does it play in Apple? Can I take my iPhone and run this? No, because this is a .NET, well, it's actually both managed and unmanaged code, but it's essentially .NET framework code that I need to use. Can you work out a way to play with it? To be honest, I'm not sure. Is there any? Well, you can, by the way you configure the scope and add tables to the scope, you can do a moderate amount of changing of shape of the data, but real transformation, no. You'd need to build that in. Yeah, no, I mean, yes, you can definitely do that. So, for example, you can filter columns out and say, I don't want to see these columns. I use the simple example, I use tables, but you can actually specify, I only want these rows replicated. I don't think I've tested it enough to find out, to be honest. Yeah, good point. So if you are building something where you're creating, where your client databases are creating new rows in a table, then you've got two alternatives. You can either use something like a GUID instead of a number, and that's certainly the approach we've used. If you are going to use a number, then you have to do essentially what people have done for hundreds of years manually, which is, okay, Wellington office, you get the numbers between 100 and 300, and Auckland office, So there's not really much alternative for that. Unless you don't replicate the ID up, generate new rows and have new IDs automatically generated up top. But then you're going to cause problems with the synchronization. Sorry.
No, it's a variant on that, because it talks about in the synchronization framework, and when you turn change tracking on, it requires unique IDs, and if you're replicating between more than one back-end server, you've got to put a client ID somewhere into your system. Now, using change tracking, does that automatically implement that? So
You do need to still have unique IDs, but you don't need to have unique client IDs. You just need a unique ID on the server table.
the application instance is creating its own unique ID and adding that to each change that it's tracking.
No, I think we're talking slightly across purposes. So if I
So you've got a remote that you sync, the one you were talking about. So you've got two couriers and one syncs with the other. So you've got two separate databases.
Yep.
They exchange changes.
Yep.
And then one of them goes to sync with a back-end a distributed store. And so does the other one. So they've now put each other's changes back into each of the other stores.
Yes, but the IDs will be the same because that's why you have to use a GUID because
It works with a GUID, but if you've got existing
it won't.
infrastructure
Yeah.
that have got old number-based stuff, I mean, you're talking...
Yeah, it won't work. It won't work with simple ints and things like that. It will work with simple ints if you, for example, use a multiple key. So the courier driver's ID and the ID that the new ID that is generated as a complex key. So there are other ways of doing it, but a GUID is much easier.
I've just been doing some work with converting an int to a big int and rolling in a client ID and a table ID at the same time. So the resultant big int is unique for every row and every table and every client.
Yeah.
But it's because there's a bunch of other code that if you've got to support a client ID, you've actually got to restructure all the code that's falling through various web services and callbacks, etc.
Right. There was a question. Sorry, there was a question at the back too.
Just to know, if you have conflict resolution, are there events from the synchronized part of the code that you can...
Yes. Yeah. I glossed over it completely, but basically you can subscribe to events for failure, for conflict, all that kind of stuff, and basically you provide a routine that will handle that particular event.
If a device gets stolen or lost, does the sync have that capability for you to delete the remote data or to actually set a...
Well, the thing is, you're not. Firstly, yes, but typically that's not an issue anyway because okay, so he's created a bunch of data, changed some data, etc. It's gone. I'm not maintaining particular state in my master database for him. I'm maintaining just information about changes that have occurred in my master database, and it's those changes that get synchronized against him. I don't kind of reserve the data changes for one person, if you know what I mean.
Can you apply any sort of filters to change tracking, like exclude relationships?
Oh well, as I said, you can specify which rows you're interested in changes in. So if I have a table of 50 rows and I know that all of these, the first 40 are not going to change and they're only going to make changes to the last 10, I can say only track the last 10. And in actual fact, I mean, as a simple scenario, you might have the master database dropping rows down, which the first 40 rows of information. So you have two scopes. You have a scope from the master database to synchronize the new rows of information with the first 40 columns of information. And then the user makes changes in the last 10 columns, and that's a new scope. And so you can actually make the synchronization very efficient. Any more questions? Thank you.